Okay folks, there's a request on carry-lookahead adder. This is what it is. So look, for carry-lookahead adder, we're gonna start from 1-bit full adder. If you look at this 1-bit full adder right here, you can find it in the textbook. I'm not going to deep drive it, and I think we have a video that deep drive this as well. From here we can find the equation for SI, which give you the sum, and the equation for CI for the carry out. Okay, if we rewrite this equation using GI and PI, okay, the CI is just a shorter form, so it's much easier for us to derive. Okay, so the idea on carry-lookahead adder is each stage is going to produce its own carry bit. What it means is the carry coming in instead of waiting for the previous stage giving you the carry. You're going to produce your own carry. So we're going to use this. Basically, we're going to use this equation. So we know that SI. Just going to rewrite this. YI plus CI, exclusive of CI, and CI plus 1 is GI and PI CI. Okay, and we know that GI is XI and YI, PI is oh, there's an error right here, and PI is XI YI. Okay, XI or YI. So GI is XI YI and PI is XI Y XI or YI. Okay, so now for let's we're just going to do 3 cases. Okay, so for I equal to 0, no changes. S0 is X0, Y0 and C0. Okay, and CI plus 1 when I is equal, so I is equal to 0, so 0 plus 1 equal to C1 equal to Z0 plus P0 C0. Okay, for I equal to 1, S1, same case here, X1, Y1 and C1. Okay, so C now is 1 plus 1 equal to C2 equal to, I'm just using this pure equation right there, so it's G1 plus P1 C1. But we know that C1 is this C1 right here is no, this C1 right here, we can get C1 right there. Okay, so we can rewrite that using C1, so G1 plus P1, and we know C1 is Z0 plus P0 C0. Okay, so C2 is G1 P1 Z0 plus P1 P0 C0. Okay, now for the next case, I equal to 2, so it's C2 plus 1 equal to C3. Okay, I didn't write the S2 because S2 is the same. So we have G2 P2 plus no, G2 P2 and C2, and we know C2 is from the one above, so G2 plus P2, okay, is G1 P2. There's an error here, this should be P1, so it's P1, so it's P1 Z0 plus P1 P0 C0. Okay, so now C2 or C3 is G2 plus P2 G2 P2 G1 plus P2 P1 G0. Okay, and P1 P2 is P2 P1 P0 and C0. Okay, so these are the math that I'm going to show you how you can use these equation to build carry-lookahead adder. Okay, so but for now, let's just look at it. This basic block right here, again this basic block right here, Okay, so you see that this basic one full adder board, 1-bit full adder board block. Right here it show you is a 3-bit because it's X0, X1, X2, 3-bit right there. You see that there's a carry chain right there. Okay, it's going to here making a calculation. That's the reason why it's called a carry chain adder. Okay, so this is what is slow you down. So so now what we basically will be using is this, and that. Okay, we're going to use that to build a carry-lookahead adder. So I have copied it and copied the equation of C1, C2, and C3 right down here. So make things a lot simple. So I'm just going to show you how we can modify that. There's no modification on the stage. This stage right here, this stage right here, we're not going to touch it. Okay, because it's already, in some sense, there's a new carry in, there's a carry in coming in. We're not doing anything different. Okay, so but now if you look at this, the C2, okay, the complication here is in C2. So so we have G1 and P1 G0. So this P1 Z0, P1 Z0, this is the term, the second term, P1 Z0. So what we need to do is take Z0 right here. So now we have P1 Z0. So what we need to do is we actually need to break this carry chain, so it's gone. That wire is gone. Okay, now we need to build the next term. Okay, so we have P1, P0, and C0. So we have P1, okay, P0, okay, and C0. There is the original carry. Okay, and this, do you see that big OR gate right there? And this gives us C2. Okay, so now the next one, this, do you see how much more complete can this get? So we have G2. The G2 is already in there, so it's P2 and G1, P2 and G1. Okay, P2 and G1. Now we break this carry connection, break the carry connection, and then the next one that we are going to build is, the next one that we're going to build in addition to that is P2, P1, and G0. So Z0 is right here. Okay, and then we have P2, P2, and P1, P2, 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 P1, and Z0. Z0, we're gonna have oh, that's Z0. So we have P2, Z0, and P1. Okay, this is P1 right there. Okay, and this go into the OR gate, and the last term is P2, P1, P0, P2, P1, P0, and C0. So we need another AND gate. So that is C0, P2. Where's P2? P2 is right here. P1 and P0. Okay, like this right there. Okay, so this is you can see that right now this is a carry-lookahead adder. It has more logic gates, and each stage basically calculated their own logic, the carry in coming in. So extra gates, and this is the original. This is the carry chain adder. This is a, as you see right here, this is a 3-bit. The only 3-bit show 3-bit carry chain adder, or a or another way to call it is a ripple carry error. Okay, and this is carry lookahead error. Hopefully this makes sense and hopefully it helps.